In today's lesson, we're going to learn all you need to know about perpendicular bisectors. As we go through perpendicular bisectors, we will see that perpendicular bisectors are, if you were to draw a segment, so let's pretend as though that segment's that there. So you would draw a segment from A to B, and now we have drawn a segment. If I were going to do that digitally, it would look something exactly like that. Now, we would normally spend some time in class figuring out how to construct the perpendicular bisector, and so that would mean that we would take our compass and we would stretch it past here, we would stretch it somewhere past the midpoint, and we would stretch it there, and there, and there, and there, and we would connect the lines, and it would go right through the center. Digitally, I can do that a little bit easier whenever I just do I can select the midpoint and do construct, and I can construct that midpoint. Now any line going through this point C will then be on the perpendicular bisector. Now if I were to take let's just say the distance from D to A. So as you see, as I move this point D around here, right now the distance from A to D is 2.89. Distance from D all the way down to B is 10.62. If you'd like to see the segments, there they are. And so as you can now understand that as I get further away from B, I'm also getting further away from A, and they are nowhere near the same. If I need those exactly the same, I'll put them, looks like close, 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 and you don't want to be this tedious about it. You actually want to figure out where it is. And so how you do that is you draw a line through this perpendicular bisector, and once you draw a perpendicular line through C, which would be there, as soon as you put D on that perpendicular bisector, somewhere, you know that I'm getting really, really close. So if we take those lines away, and I construct from A to E, if you'll notice E is bounded. I can't move anywhere off of that segment. E is bounded. So if I draw A to E, I know that E must be on that perpendicular bisector. Geometrically, I also know that both of those are exactly the same. So how that works is in a drawing. If I were to take some sort of line like this, and I wanted to construct an isosceles triangle. So if I need an isosceles triangle, what I can do is I can go through, and I will go through the steps to find the midpoint, and then I will draw a perpendicular line that would go exactly through that midpoint. I know that that is perpendicular. Now what will happen is any point that is on that line will also be equidistant from the two endpoints. So from there to there and there to there has to be exactly the same. So therefore that is an isosceles triangle, and that would mean that these become the bases. That is our discussion on how the perpendicular bisector is constructed and how it works and what it looks like. You will be seeing some problems later on using that. Thank you very much.